Hello and welcome to a new episode of the CTO Show with Mehmet. Today, I have a rich episode where I will be discussing multiple topics between deepfakes and social engineering, then discussing quickly about RPA, robotic process automation, then an old debate about buy software ready or build it in-house, and the last one is how data science is often compared to an iceberg. Let's get started. The first topic today is regarding deepfake. I brought this topic before, but today I saw an article talking how deepfakes are getting more and more accurate. Deepfakes, the technology that allows for the manipulation of videos and images and even sounds to create false content, is becoming increasingly accurate. What once was a tool for entertainment is now a threat to our security and trust in information. As the technology continues to improve, it becomes harder to distinguish between real and fake content, make it easy for bad actors to spread misinformation. It's important that we stay vigilant and aware of the potential dangers that deepfakes can pose and work to develop ways to detect and prevent them. One use case is generating realistic photos of high-profile people at organizations and create social media accounts using them, and then try to do social engineering using these profiles. Of course, there are multiple ways we can detect that from technology perspective. So there are some tools that we can leverage, like reverse image searching and some dedicated software for that. But there's an easy and straightforward way to detect these fake accounts. So the first one is to check the profile, how authentic it is. Has it been for a long time? Does it have enough connections? But one of the key factors that can help us in detecting these fake accounts is to see if this profile is sharing online and he's getting likes or comments from his or her colleagues. It's a very good way to spot if an account is authentic or not. So my advice here, be very careful, because really deepfake, it will be a headache in the future from social engineering perspective and information security perspective in general. The next topic today is about robotic process automation, or RPA. For people who have heard about the technology but never thought what it can do, so I thought I will discuss it today in this episode. So RPA allows businesses to automate tasks such as data entry, customer service inquiries, and even financial reporting. This means that employees can focus on more strategic and value-added activities rather than spending their time on manual or repetitive work. Using RPA, businesses can also increase the efficiency and accuracy, reduce costs and errors, and improve compliance and governance. The technology can be used across various industries and business functions like finance, human resources, supply chain management. Also, it can be a good fit for businesses who are willing or having 24/7 operation, because RPA can handle high volumes of data and transactions. It makes the perfect fit with organizations with high transaction volumes or operating in multiple time zones. RPA can also be easily integrated with other technologies such as artificial intelligence, machine learning, and natural language processing, allowing for more sophisticated and intelligent automation. I see RPA for businesses who started to use it and businesses who are willing to use it a key game changer to increase productivity, efficiency, and competitiveness. It's a tool that can help any business to streamline their processes, improve the accuracy, and free up the employees to focus on more strategic, high-values activities. Time will show us how businesses and organizations will be using this technology to stay ahead in today's fast-paced business environment. Now, another topic I want to talk about today, it's a debate. I remember when I was sitting on the other side, on a customer side, sometimes it was brought up if we are willing to have a software, we used to ask, should we buy it or should we build it? The reason why this debate came back is because the current economical situation. So everyone is looking to cut costs and have more efficiency in their budgets. So here we go again with this debate. Building a software in-house can be a great option for organizations that have specific needs that cannot be met by the off-the-shelf solutions. It also allows for more control over the development process, customization, and scalability. However, the pitfall here is it can be time-consuming, costly process, and requiring significant investment in resources, including development team, hardware, and software. On the other hand, buying a software from a third-party vendor can be faster, more cost-effective. It can also provide access to the latest technologies and features, as well as, of course, support and maintenance. However, it may not always meet all the specific needs of what you are trying to build or what you are trying to achieve. Plus, you cannot have all the customizations that you are willing to have. Ultimately, the decision whether to build or buy should be taken after every stakeholder responsible for this project that the software will touch on sit together and look at these three specific things. First, need, budget, resources. After that, it's a good idea to start giving a weight for each one of these three with the pros and cons for each option, and carefully at the end consider the long-term implications for the organization. In conclusion, whether to build or buy a software, it's not an easy decision. It needs careful consideration. And here I want to highlight that sometimes you might have the human power, you might have the budgets, but you don't have the infrastructure. And the latest technologies that allowed us to get a lot of additional features or a lot of additional customization exist only, for example, in the cloud. So can you bring the same cloud-like architecture and infrastructure to your data center? You need to think about it. And the days ahead will show us who will win the debate. The last topic for today is data science and how it is compared to an iceberg. Data science is often compared to an iceberg because we see only few layers, I would say, and the rest is a hidden layer from us. So let's deep dive, because when we say data science, it's a very broad word. What is inside this iceberg? So we have the top. The top is data collection. The first step in data science is collecting data from various sources like sensors, IoT devices, databases, surveys, social media, sentiments, and so on. And this is where you do your first step. This is the top of the iceberg. Then, just below it, which is also visible, is data cleaning and preparation. So once you have the data collected, this is where it needs to be prepared for analysis. This can be time consuming, requiring significant amount of effort, and this is why it's considered just below what is seen on top. Then we deep dive on the submergent version of the iceberg. So here you have data exploration and visualization, where data scientists can begin to explore and visualize the data to uncover patterns and insights. This is where the true value of the data is revealed. The next layer down is model building and evaluation. So once the data is understood, data scientists can build models, and models help us to make predictions, identify trends, and so on. And these models, you always keep evaluating them and refine them for accuracy, and you need to keep also maintaining them. And this leads us to the last part of the iceberg, the deepest part, which is the deployment, maintenance, and security. So this is the first step where you have your models. You need to start to evaluate, maintain, and deploy them and monitoring them for security, for accuracy, and other aspects. It's pretty much here where you need to put an eye on the security of this data, because you don't want to lose all the other layers which are above, and you need to keep your data available for you all the time. In summary, data science is a complex field. It requires many different skills and expertise. The visible part of the data science in the iceberg example represent the small amount of data collected and cleaned. And then we have the hidden parts, which is the majority of the work, which are data exploration, visualization, model building, evaluation, deployment maintenance, and security. Thank you very much for listening today to this episode. I hope it was informative. I'm always looking forward to hear your feedback as usual. And as I promised, soon we will have our first guest in the podcast. And until we have that guest, keep following our podcast. And I hope to catch up with you soon. Thank you very much.